Hello student, I am Dada Pires from Government Degree College, Chennagiri. Today we like to discuss on the Maxwell distribution law, and this is the topic for the Downhill University of paper 6th of the 5th semester. Let's we go, and this is the Maxwell distribution law, which is come under the statistical mechanics. So today's objectives are to be learn. So what are the basic concepts of the Maxwell's distribution law, and we should gain the some knowledge and knowledge of the derivation of the Maxwell's distribution law. So after this session, you will be learning about the Maxwell's laws properties and its applicable to the which type of the molecules, and also learn the derivations of the Maxwell's Boltzmann law. And before this we are going, so we must know the classical law. Classical law is the Newtonian physics which applies to the Maxwell's Boltzmann law. So there is a free electrons are there, they obey the classical physics. So and there is another one is the Boltzmann entropy theorem. The entropy is the disorder in the systems. So and this Boltzmann S equal to K into log P, P is the probability. So and another one is the Stirling law, and the expansions of this Stirling law using log factorial of the log of Ni particles equal to Ni into log Ni minus Ni. This is the Stirling law. Let us we discuss see in the next slide. So as we know that Maxwell's Boltzmann law is applicable to only a identical and it should be a distinguishable particles. So and also this MB distribution law obeys the classical law. They does not obey quantum's laws, they obey only classical's law. They have any spin, it is not particularly applied to the half spin, 0 spin, 1 spin, it can apply to any of the spin, and it does not obey Pauli exclusion principle because it come under the quantum's law. So it is only obey to the classical laws. And example for this Maxwell's Boltzmann law can be seeing that the molecules of gas, in gas the molecules are freely moving. This obeys the Maxwell's Boltzmann distribution law. So how can we derive the Maxwell's Boltzmann law of distributions functions? Let us we see here now. So consider a system, it consists of a number of particles which are identical and distinguishable. Distinguishable means they are separate like A, B, C, like this one, they are distinguishable particles as in gas. So there is number of particles N1 and N2, N3 like this, and each molecule N1 have energy is E1. So N1 have energy E1 and N2 energy is E2. So like this, and N3 is energy E3. So like this way they are going on. So they have a number of particles have each energy is if there is a Ni particle, the energy is Ei energy. So then N is equal to can be given by, so N is equal to N1 plus N2 plus N3 up to the sigma Ni. So nth particle. So in general the Ni particle of the molecule have energy is Ei. So then E equal to the total energy equal to N1 E1, N2 E2, N3 E3 plus like this way up to Ni En plus up to the nth one. So we can be see this here. So if there is a N and E are the constants, here the number of particles and energy is constant. So their differentiation is constants usually. So dN is equal to dN1 for N1 particle, dN2 for the N2 particle, dN3 for the third particle. So like this way you proceed further. So derivative of the sigma Ni particle. So total dNi is equal to 0. So differentiations, because it is a constant, it gives the value 0. Similarly for energy, the sigma E dNi is equal to 0. So this distribution law we know that. So the distribution law corresponding to the equilibrium state, they have more probability conditions. So, there is equilibrium state which have the most probable conditions is applied here. So, you can be applied, hence there is a gas is in assumed to be a thermal equilibrium, that in this steady state we apply the Boltzmann entropy law, that is S is equal to K into log P, where S is the entropy, K is the Boltzmann constant and log of P is the probability. So, entropy is nothing but it is a disturbance in the medium, the disorder in the system. So, according to this Boltzmann theorem, the probability of the particles distributed is given by P is equal to pi into A to the power of Ni and Ni factorial. So, pi means is the product symbol, just like we use sigma as a sum, sigma na ನಾವು sum ಅಂತ ಹೇಗೆ ಯೂಸ್ ಮಾಡ್ತಿದ್ವೋ. So, in this constructs the pi is the product of there is number of particles there, their product is can be represented by this caps pi. So, and here is the Ni is the number of particles, as you know that, but A is the number of the elementary volumes of particles of entropy and probability. So, A is the number of elementary volumes. So, then put this p value in the Boltzmann law, that is S equal to K into log P, that is S by K is equal to log of P means pi into A to the power of I Ni by Ni factorial. So, let me expand this one, this is the product, this is the product one. So, that can be converted into sigma. So, after log apply it is converted into sigma. So, Ni to the power of into log Ai minus log Ni factorial. So, see here this is the log Ni factorial, it is obeys the Stirling law. Stirling law says that log Ni factorial is equal to Ni into log Ni minus Ni. Where is the factorial? Log of the factorial is comes. So, you apply the Stirling law. So, that is log Ni factorial is equal to Ni log Ni minus Ni. So, just this one is replaces with this one. So, we can see here S by K equal to sigma Ni log I, same as it is. So, we put here minus into, that is minus into Ni log Ni minus into minus plus Ni. So, this is the expansion of the log Ni for using the Stirling law. So, as we move further, so see here after let me differentiate, that is the given one. So, S by K is equal to sigma Ni log I Ni, this let me differentiate ds by dk sigma, this is the product rule we are apply here. So, log Ai constant into n is the differentiation is 1. So, dn 1. So, again Ni is there. So, log A is the constant. So, its terms is going to be 0. So, then Ni is remains. So, log Ni is here 1, the differentiation of Ni is 1. So, into dni and minus a Ni into log n differentiation 1 by n get cancelled there and it simplifies just only minus dn and n is there. So, its differentiation is dni. So, after simplify it, we see here ds equal to, after taking dni is common out of this one, we remain is log ai log ni and dni dn usually cancel here. So, remaining states log ai ni. For the steady state ds is 0, there is no change in their entropy. So, there is entropy is constants, that is ds is equal to constant there. So, then just only these two terms are only remaining, that is log ai ni minus equal to 0. So, and this law is applied to the using the undetermined multipliers, the Lagrange's undetermined multipliers. This value can be corrected as log ai minus log n I is equal to 0 is using the undetermined multipliers, we can be write down same as it is. Some there are two constants are used, that is log a minus log n I minus lambda minus beta E I equal to 0, where lambda and beta are the constants here. A is the energy of the ith particles. After this, you are seeing here, just take this outside of equals, that is log of and this log m minus log n I for log n formula, that is log m by n, that is log a I by n I is equal to plus lambda and plus beta E I, and take log this outside, that is a I by n I e to the power of log, after crossing the equals turns to exponents, exponent, that is e to the power of lambda beta E I. But we know that only we want the number of particle distributions here. So, we can say that that is n I is equal to a I, that is replace this one, just transfer this one to the denominator. So, that is n I is equal to a into e to the power of lambda beta E I. So, here is the Boltzmann law derivations, and this is the exponentially the value decreases here. So, we are n I is equal to a into e to the power of lambda plus beta E I is the required distribution law of Maxwell's and Boltzmann ones. This is all about the today's sessions. That is some multiple choice. Let us check this multiple choice, what understand level we are learned from here. We know that in MB statistical particles is or are identical, are distinguishable, are indistinguishable, or both A and B, which you says yes, absolutely it is also identical and also distinguishable, means answer is D. So, in MB statistics usually particles have which type of spin, whether it is a 0 spin or integral spin or any spin or even spin only. So, it only applicable to yes any spin is the particles can have any spins. This is the MB statistics laws. So, on this MB statistics law obeys which type of laws is obey, whether it is obeys quantum laws, classical laws, Pauli exclusion principle, or integral spin off, which one it obeys? MB statistics law? Yeah, yes, it's obey only classical laws. What's there? Quantum laws, it's obey another one. So, Pauli exclusion principle is come under the quantum mechanics, so it does not obey. So, integral spin does not matter. So, only obey the classical laws. So, okay, thank you for all these things, well learned. Okay, bye.